Hello everyone. Today we are going to talk about how we can find multiplication expressions by using arrays. But before we begin, we need to go over some key vocabulary. In the next slides, you will learn some words that are going to help us on today's lesson. Before we begin, you should know that an array consists of equal rows and equal columns, normally creating a square or a rectangle. The first thing we need to know when multiplying with an array is the difference between a row and a column. A row are things lying down side by side in a horizontal line, where a column is an arrangement of figures one above another in a vertical line. So remember, rows are in a horizontal line and a column is in a vertical line going up and down. So let's take a look at this array. How many rows are in this array? Correct. We have 1, 2, 3 horizontal rows. Next, how many columns are there? Correct. 3. We have 1, 2, 3 vertical columns. Very good. The next vocabulary word you're going to need to know is the word factor. Factors are numbers that you multiply together. In this example, you will see that 2 times 3 are the factors to 6 because 2 multiplied by 3 equals 6. The next word is prime. A prime number is a number whose factors are only 1 in itself. We'll get into that later. And for composite, it is a number that has more factors than just 1 in itself, the opposite of prime. Now that we have learned some key vocabulary words, let's dive into our lesson. Before we begin, you're going to need a whiteboard and a whiteboard marker. Also some manipulatives that you can use to create your own arrays at home. Let's start with the number 12. If you had 12 discs, how many arrays can you create with only 12 discs? Let's try to do it together. First, let's try creating a row of 1. If we have 1 row, how many discs would be in each column? If you did this on your whiteboard, you are correct. We have 1 row of 12. So this dimension is called a 1 by 12. Dimensions can also be known as factors. So far we know that the factors of 12 are 1 and 12. Can any other numbers create dimensions? Let's try. You can also use 2 rows to create equal columns of 6. So you have 2 rows and 1, 2, 3, 4, 5, 6 equal columns. This dimension is a 2 by 6. You can also create one more array using 3 rows. In the 3 rows, you have 4 equal columns, this dimension being a 3 by 4. For dimensions can also be considered as factors. So we know that the factors of 12 consist of 1, 12, 2, 6, 3, and 4. Very good. Let's try creating an array with another number. How about 7? How many arrays can we create with the number 7? Use your whiteboard to draw out how many equal columns and rows we can create with using the number 7. For the number 7, we couldn't come up with any other arrays. So the only factors for 7 are 1 and itself. That means that 7 is a prime number. We learned that earlier in the video that a prime number are numbers that only consist of factors of 1 and itself. So to multiply to get 7, you can only multiply 1 times 7 to equal 7. So 7 is a prime number. If we look back at the first number we did, 12, it had more than 2 factors. We used the factors 1, 2, 3, 4, 6, and 12 to create arrays for the number 12. Since a 12 has more than 2 factors, that means it is a composite number. Remember, a prime number can only have 2 factors, 1 and itself, and any other number that has more than 2 factors, it's considered a composite number. 12 is a composite number. Let's try creating one more array together. How about we try the number 9? Use 9 discs to create as many arrays as possible. Then we'll see how many dimensions we came up with. When creating arrays, we know we can always start out with 1 row. So if you use one row with 9 columns, your dimension would be a 1 by 9. Did anybody come up with a 2-row dimension? No. How about a 3-row dimension? Let's try it out. So if we have a 3 rows, 4, 5, 6, 7, 8, and 9, we have a 3 by 3 dimension. Could you do it with 4 rows? Try it on your whiteboard. So we couldn't use 4 rows or 5 rows to create an array of 9. So that means the factors of 9 are 1, 9, and 3. If 9 has 3 factors, does that make it a prime number or a composite number? Composite, you're right. 9 is a composite number because it has more than 2 factors. Let's do a review on what we learned. We created arrays with the number 12, 7, and 9. These are the factors that we came up with. For the number 12, we came up with 1, 2, 3, 4, 6, and 12 as the factors. For 7, we came up with the numbers 1 and 7, determining that 7 is a prime number. For 9, we only came up with 1, 3, and 9. Talk with your partner and see if you can see any patterns. Are these numbers odd numbers, even numbers, prime, or composite, and why? During your discussion, one group came up with the pattern that odd numbers only have a few factors. Is that true? Try doing an array of 15 and see how many factors you can come up with. In our previous examples, we used the numbers 7 and 9, which are both odd numbers. For 7, we can only come up with one array, which gave us only 2 factors. 7 is a prime number, so its only factors were 1 and itself. Then we used the number 9. We used the number 9 and created 2 different arrays. So the numbers that we used for factors were 1, 3, and 9. I had just asked you to create arrays for the number 15. How many arrays did you come up with? I'm hearing 2. You only came up with 2 arrays. So how many factors does 15 have? Correct. 15 has 4 factors. You should have created the dimensions of a 1 by 15 or a 3 by 5. Given 15 the factors of 1, 3, 5, and 15. Now 15 is an odd number and only has 3 factors. Does that fit your prediction of odd numbers only having a few factors? Let's think back to the number 12. 12 is an even number. 12 is also smaller than 15, but how many factors did we come up with for the number 12? Yes, so for the number 12, we had 1, 2, 3, 4, 6, and 12. 12 has 6 factors, where 15 only has 4 factors. Write in your math notebook if you believe that even numbers have more factors than numbers that are odd. Looking back at all the arrays we created to date, can you think of any more factor patterns? In our small group discussions, I heard someone say that they think all prime numbers are odd numbers. Do you think that is true? On your whiteboards, write down all the prime numbers that you can think of. Are they odd numbers or are they even numbers? Are there any even numbers that are also prime? Starting from the number 1, you came up with all of these prime numbers, which are also odd numbers. The exception for prime numbers being odd numbers is the number 2. 2 is the only even number that is also prime. Good job. For your independent work today, you will be creating more arrays on your own. You will be finding the factors and any more factor patterns. Come back to class tomorrow and be ready to share any more factor patterns that you found. Have a great day. Thank you.